Welcome to the channel. Since my last video unboxing, I already took these rails of the TRX-6 and started putting things together a bit, mainly for the chassis. I put the bumpers on, here you can see from the bottom side. I have quite a lot of upgrade parts. Almost everything here you see is an upgrade part. These bumper attachments, whatever they're called, brass ones in the front, in the back. Then I got an aluminum servo holder here, aluminum motor holder, aluminum this bottom plate where you attach all the different other bits and pieces, upgraded stainless steel screws everywhere. This part here, it's also aluminum, this rear support, whatever it's called. This middle part here is the only part which is not aluminum, because I couldn't find an upgrade part for this one. However, it seems to be, despite I couldn't find an upgrade part, it's okay. It seems very rigid. I will put into the description links to whichever I bought and from wherever I bought them from. Majority of these parts are from Integy through either Amazon or from their own online shop. These are just random ones from Amazon. Why did I buy these many upgrade parts? Well, I wanted this structure to be as rigid as possible. So there's not much flex, as you can see, it's quite rigid. I was wondering, do I also need to have the supports for the body and the suspension also in metal? And yeah, if you bend these, they're quite flexible and flimsy. And the front not so much, because the bumper is not so big. But the rear is definitely very flimsy and flexible. Why do I want to make this rigid? Okay, here's the bit of a kind of a, I don't know, lecture. Whenever you design a robot or whatever, a vehicle, there are two types of components when you think about like how it bounces, how smoothly it rides and so on. There are those which you cannot control, those components. You cannot control how they behave, and those which you can. And from engineering and physics point of view, when you can control something, it means you usually can even make mathematical equations out of it. You can calculate how it behaves in certain conditions and so on. Now, this is very much simplified. So everything can be engineered and calculated, but you need to consider it in your design. Why chassis should be rigid as possible? Well, these flexible parts, these are very non-linear, meaning their flexibility and basically suspension-like properties are not linear. So more you bend, it behaves differently. They're also very difficult to mathematically estimate. So, and they're not controllable. You can't do much other than just replace them with stiffer parts. So, I'm replacing everything that flexes with a stiffer part so that this whole upper part of the chassis is rigid. I'm not doing it because of the weight and not because of the strength. I mean, I've noticed that the traction parts are really tough. It's just due to the nature of plastic and how it's designed, they flex. Maybe it's okay for some other purposes, but for my purpose of making this autonomous, I need to have very high control and ability to control and adjust how this bounces, what the ride is like. And it doesn't need to be guesswork. It doesn't need to be experimental. I mean, I will do some of that just because I'm too lazy to calculate. But if you design things correctly, you can control things to mathematical level. You can calculate when it behaves, it's called frequency response of this vehicle or system. So I want to make this rigid as possible. What other parts do I have what I need to change? Well, what I can control, the suspension. That's the point of it. You have the shock absorber, which is basically stiffness, and you have the spring, which adds more bounce and ability to react. What I want to do is have this rigid as possible, remove all these uncontrollable flexible parts, leave only suspension, and do all the adjustment, because the suspension you can mathematically model, you can calculate, you can change the oil, the spring, and everything according to whatever specifications you want, how it should ride. So that's important. But then there's still one more thing. Even if I replace all of these parts metal, there's some part of the suspension is fine, but when it comes to the axles and everything, even if I make everything metal, there's still one unpredictable part. That's the tires. Now, there's a lot of research done in the world about tires, how they ride, what their frequency response, how they behave. So when you have a car that's designed to use specific springs, shocks, and tires to certain pressure, and yeah, funny enough, chassis is rigid. Let's say the modern carbon fiber ones extremely so. It means that they have everything else rigid, and then those parts which they can control the suspension, they adjust. And then comes the more difficult one, is the control of how the tire behaves, because it behaves also like the shock absorber spring combination. Bounces, and it also absorbs movement, basically dampens movement. That one is dependent on the material, the shape, size, surface, tire pressure, what's inside like foams, whatever. This is the part, unfortunately, in this case, which I need to probably just experiment, as it is, it's much more controllable, because I believe there's so much more research done on actual car tires than is on RC tires. I don't know, maybe I'm wrong, but so the tires will be the one part which I cannot control. The chassis and every mechanics will be as rigid as possible, so the parts that I can, actually I don't need to control. And then the shock absorbers and the springs will be the one which I will control and adjust everything. So it's about what you know and can control and what you cannot. Minimize the amount of things you have no control over. That way you can design, using mathematics, physics, whatever engineering discipline, you can design the behavior of the vehicle to be exactly the way it is. You can make it smooth, wavy, you can make it survive kind of average way in many different conditions, or you can make, let's say, like F1 cars, which are, or some of the fastest cars in the world, they are adjusted, or they themselves adjust, but they adjusted to extreme conditions, like F1 cars. When the suspension, let's say dirt or some obstacle, small one goes under the tire, happens a motion which is out of the frequency range of behavior of what was planned, the whole thing flies up in the air and it crashes. So it's designed to be to the extreme. It's not by accident, it's designed to be that way. The same applies for everything. You need to consciously know which components you choose and where you want to have that controllability, adjustability, and how much unknowns are you willing to take. In my case, this wobbly plastic was under unknowns, so I need to get myself rigid mounts for the... Maybe I will keep these just somehow as a protection against, but let's see. And no, weight is, of course, people are adding all kind of weights to their crawlers. I believe this is also a crawler. Autonomous crawler, maybe that's a better name. I didn't take this because of weight. I took them because A, it's brass, it's very easy to machine, and it's rather robust. It has a lot of holes in it. So when I'm going to install sensors back and front, there are lots of ready-made holes there. I have to say though that the quality of these Chinese ones, this one perfect, same batch, same maker, I hope. This one perfect, rear one, yeah, crappy. But it'll work anyway, I'm going to be cutting pieces out of it. Integy parts, I've heard some negative stuff about Integy, but honestly, at least in these aluminum parts, like the servo holder, the motor mount, this middle part, and this one here, no problems, whatever. In these brass ones, especially one in the rear, I had to file a bit around. I think because it's been machined a bit wrongly. One problem with Integy only in the motor mount, which was attaching to the rail, in the equivalent plastic part, what the part that goes inside the rail, there's a sharp corner, 90-degree angle. And I think in order to save money from having to change the tool every time for machining, they just made it really, really large radius round. So I had to file some pieces off in the railing, these rail attachments to be 90-degree angle so that this would fit in place. So I guess I don't know, either they forgot it, but maybe it's just to save money. The fun part is that then these other Integy parts didn't have any of those problems. Just this motor mount I had to file off some angles. So when you take these, keep the original plastic part and compare them, especially corners, and compare them together, see where the differences are. And just take a small file. Hold on. Yeah, just take a small file like this, little file, and file off whatever is needed. With aluminium and brass, it's relatively easy. Because there will be a lot of metal parts, and it's more difficult to control the point of balance, kind of where this one is, to be center. Ideally, it should be in the center. Again, it's much more easier to control when it is in the center. How your design works and adjust everything when it's in the center. Center. So it's pretty symmetric otherwise. The only problem was that this internal stuff is not easy to distribute. It's where it is. I now have no choice. So I added a bit more extra weight in this form of brass. And if I balance it out, I can't really do it in front of the camera. It's sliding too much. But it's approximately in the middle, in all directions. So the center point of the mass is nicely in the middle. Despite this would shift it a bit differently, not exactly to the center, but putting these heavy parts, which are about the same in both ends, I make it shift it back to being about center. So it's all about controllability and that you choose your design choices where you can control and so on. I've seen so many videos, people reviewing brass parts, adding and wondering why it doesn't work. To be honest, I don't know the backgrounds of all of these people, so I cannot say what their motives are. Many of the tests, even the commenters in them, see why they failed and comment onto this. But a lot of the parts have different purposes and why you choose them. But if you want to have maximum crawling like this one, I think you can fit angle and so on, it's a sum of many things. And in many cases, for example, you saw the car tilting, and the reason why the point, either if the weight is in the wrong end, the center mass point goes over its supporting edge and it goes backward, obvious. And even if it's otherwise okay positioned, but then you have a soft tire which squashes under the weight and immediately shifts the point over a certain point and the whole thing tumbles down. So then it's a case of having wrong tires or suspension. So you can design these kind of things to do almost, well, not almost anything, but a lot. But you need to decide knowingly what to, not just randomly trying out things like put this here. Oh, it's fun, but it's very difficult to draw any sensible conclusions about the why it happened a certain way and why it didn't and what should be done. I will now unfortunately need to wait quite a long time for ordering these suspension mounts. I'm trying to source them from Integy had some nice ones. I read that Sam's something like that had nice ones. They have the problem that, at least what I think is that when you have this one-sided spring connection, basically the whole loading of the spring is on a screw. And what most people don't realize, screw is not an axle. An axle is made usually from different kind of steel, and it's able to perform, and it's differently attached. Screw is a screw, And in most cases, the screw is used to distribute the load elsewhere, not they take it not for itself. So, like you see here in the front and everywhere, Traxxas uses 2 points for the screw attachment of the suspensions springs or the shocks. So there's a reason why they did that. And so far, I only found Integy having these 2-point attachments. And then I will get a metal one, this attachment between these 2 points to make it rigid enough. So I think then I can easily put aluminum plate, whatever I want, build the chassis, body on top here. I have already a lot of other parts. I have a gearbox, metal one here. I will make a separate video of that one. I need to get a new servo. The servo that was in this one was horrible. I need to get electric motor because this will be significantly heavier than standard ones. I definitely need to get a bigger motor here. Some other upgrades. I have already lots of upgrades for the power transmission, but there's no time for them yet as I need to still fix a lot of things here. Yeah, I think gearbox will be the next one. I bought a metal one. I think it's also, actually it's not Integy, it was someone else. But wherever I do this, I will put the links to the descriptions. Yeah, looks like this. Quite heavy already. Some of the choices of the components are, due to the current situation, A, I couldn't get anything else. B, like this one, which has a solid, but there's no holes in this one, only available from Integy. The same here, this rear part here, only available from Integy where there's no holes, so no dirt goes through those parts. Yeah, but I'm really excited about this, and now I have this. Yeah, there's the stainless steel screws everywhere. Actually, I got this kind of kit. They had a TRX-6 kit of these stainless steel screws. The local shop didn't have that, they run out. So I just took one of theirs, which is generally meant for Traxxas TRX-4, and I'm hoping there will be enough of different screws. Anyway, there will be a lot of components not going in here anyway, especially the plastic parts. I will try to put metal sides here and so on. And I also got myself a box TRX-6 bearing kit. Yeah, maybe I will make a separate video about these and review this stuff. Thank you very much.